Hello ladies and gentlemen, this is Asif Imnad again. It is in continuation with the previous core Java session part 1. In last session, we have seen some basics and important core concepts of Java. I hope they are clear for you. Now let's proceed ahead and we'll be continuing with abstract classes and interfaces. And after that, we'll definitely have a look into exception handling and finally the important one, that is collections in Java. So let's get started, guys. Okay, so as we said, our objective is to cover what is abstract classes, when to use abstract classes, the rules for defining abstract classes, and once we complete with the abstract classes, we'll talk about interfaces and we'll see what is interface, and we'll definitely see what is the difference between abstract classes and interfaces, and definitely how to implement interfaces. Yeah. So to start with abstract classes, let's understand abstract class first. Okay. So when I say abstract class, what do you understand or what does it mean? So abstract class is nothing but a conceptual class, right? The name itself says that abstract. So when I say abstract, abstract means something imaginary, something conceptual, right? So what we are doing here is we are trying to implement each and everything, that is whatever we have in the real life, we are implementing that in the software domain, right? So some things are physically actually available, right, which we can touch, which we can feel, those can be easily converted, right? So if I say a vehicle, right, or if I say a vehicle called as an Tata Indica, right, so I can easily touch it, I can easily feel it, so I can convert that real life entity into a software domain, right? But when I say abstract classes, this is something related to the concepts, right? So that means what? There are some of the things in the real world scenario, those are conceptual, those are not real. So how do I convert those conceptual things into a software domain? So if I simply say a bank account, right, we have some concept called as a bank account, but if you consider this scenario, bank account cannot be touched, cannot be felt. Yes, it doesn't actually exist in the real world entity. Yeah, but still we have some of the operations on this, like withdraw and deposit. Yeah, we have to perform some operations called as an withdraw, operations called as an deposit, but this bank account entity does not actually exist in the real world, right, which we cannot touch it, we cannot see it directly, right, but it has the existence in the real life, which is imaginary. So how do I implement those imaginary or abstract things into a software domain, right? So to implement conceptual things, to implement imaginary things into a software domain, I should go for abstract classes. Okay, that's the main first use of abstract classes. Even whenever we say that vehicle or employee, right, if I say calculate a top speed of vehicle, if I say calculate a top speed of vehicle, is that possible to calculate a top speed of vehicle? I'm just saying vehicle, I'm not specifying a specific vehicle. Rather than this, if I say calculate a top speed of Audi Q7, now I'm specifying a specific vehicle, right? If I'm specifying a specific vehicle here, then probably I may write a code for this, I may write an implementation for this method and we can implement it. But when I say calculate a top speed of vehicle, I'm just saying vehicle, I'm not specifying a specific any of vehicle, right? In that scenario, I cannot implement that specific code or implement that specific scenario, right? So how should I go for this? So your vehicle class, your employee class should be abstract classes. So in most of the scenario, if you see the base most classes, the classes which are generic classes, the common classes are abstract classes. Getting it? And we call other classes, the classes which we have implemented till now, are called as concrete classes. Okay, the concrete classes means the classes which has some implementation, which has some definition, which has some methods. right? Methods with some definition are nothing but the concrete classes. Now we have something called as an abstract classes. Abstract classes means conceptual, imaginary, which actually doesn't exist in the real life, which cannot be felt directly but can be implemented in the software domain. Getting it? So to implement imaginary concepts into a software domain, I should go for the abstract classes. So mainly for this vehicle class, for employee class, even for a shape class, I will implement, or I'll go for the abstract classes in this scenario. Okay, so even if I consider, okay, we'll implement this shape demo so that we can understand why should we learn this abstract classes and how should we use this abstract classes. Just to understand this, yeah, I'll take a shape example again. To implement shape, suppose a shape can have methods called as an calculate area, right? A shape class can have methods called as an calculate area. Okay, so if I say calculate area of a shape, if I simply say calculate area of a shape, will you be able to write down the code for this? Probably not, because what shape, which shape? I don't know the specific shape, right? So if you don't know the specific shape, how you can calculate a shape area? Getting it? Unless and until I don't specifically specify what shape, right? So rather than that, if I say calculate an area of a shape called as a circle, probably I can calculate this, right? Getting it? So because I have a formula to calculate area of a circle. So we have pi r square, right? 3.14 r into r. So I have a formula for this, but if I say calculate area of a shape, I don't have any formula to calculate a area of a shape. Getting it? So in that scenario, I have to go for an abstract classes. That's amazing. Okay, so let's implement and let's see how we can create abstract classes, and with the demo we'll see how to implement it, and how we can create abstract class, how we can create abstract methods inside the abstract class as well, and we'll talk about the rules as well. Okay, so as you can see on a screen, abstract classes cannot be instantiated, objects cannot be created, right? If I'm saying objects cannot be created, that means what? As we cannot touch or we cannot actually feel the objects which are not present in the real life, so the same way we cannot instantiate the object, or we cannot directly access those objects into the abstract classes as well. Getting it? Okay. Abstract classes provides a common root for a group of classes nicely tied together in the package. So this is basically about the generic, this is basically about the common, right? So whenever you have some common features, generic features, number of methods, so in that scenario, create abstract class. A base most class is an abstract class. So mainly we have a employee, vehicle, shape type of classes as an abstract classes, right? And because these classes, generic classes, contains the most common methods, right? So in that scenario, I'll create abstract classes for this base classes. Okay, so let's start with the Eclipse directly, and we'll be talking about how to and we'll definitely see how to implement this abstract classes, right? Okay, so let's start with the demo, and I'll open Eclipse IDE again. We are using Eclipse IDE, that is Eclipse Luna. Let me start that Eclipse. I'll run this. It will take some time to open. I'll keep the same workspace which we have used recently, that is Java demos. It will take up some time to start. So it's loading. Yes, it has started. Let me close all of these classes which we have created recently. Okay, so on left hand side, if you see, we have a project explorer. Let me create a new project. We already know how to create a project. I'll right click, I'll say new Java project, and I'll create a demo called as an abstract demo. Okay, I'll give a project name as an abstract class demo or abstract demo. Explore, and inside source I'll create a package and the class again. We should remember the standards. I have to create a package first, namespace dot organization name, that is Persistent Systems Limited, followed by say demo, and type of classes what you gonna store inside this under this. Okay, so for now I'm gonna store the demo type of classes, so I'll say psl com.psl.demo, a class name as abstract, yes, abstract demo again, and this is my main class which contains public static void main. Okay, I'll keep this class aside. Fine, this is just a caller, this is just a client. From this class I'm just gonna give a call to the different classes. Okay, so let me create some different classes as well. So we were talking about a shape class, so we'll take a same shape example. In shape class, to implement this, I'll create shape class as an abstract class. Why? Because when I say a shape, in that scenario, if I tell you to calculate the area of a shape, it's not possible to calculate the area of a shape, because this is a generic term. I am just simply saying shape, calculate area of a shape. No one can calculate an area of a shape because we don't have any formula to calculate area of a shape, right? So you need to specifically put it down, what shape, which shape, right? But we know that shape will contain some method. Yes, shape will definitely have area, shape will definitely have circumference, right? Yeah, so in that scenario we have to write down these methods, but we don't have the implementation. So let me create a shape class called as an shape. S is in capitals. Okay, and I am creating this class as an abstract now. So abstract is a keyword, and this is very simple. So simply I need to put a abstract keyword in front of class. Okay, so now I can say that this shape class is an abstract class. So shape contains the method called as an calculate area, right? If shape contains the method called as an calculate area, let me write down that method. So I'll say void calculate area method, and if you see, we are using the standards here, that is the class shape is in capitals, S is in capitals, calculate area method, this is a method, so C is in lower cases, areas A is in upper cases. Fine, and yes, and I am saying shape. Can I write a code here? I am saying calculate area. If you say calculate area for a shape, I cannot put down a code here. I don't know the formula to calculate area of a shape, right? So in that scenario, what I need to do, I cannot give a body, I cannot write a code here, so I'll end it with a semicolon, right? So I'll close that body, I'll not implement this. So if you are not implementing this, that means what? This method is an abstract method. Are you getting this? So as I'm saying, this method is an abstract method, that means it doesn't have any body, it has ended with the semicolon, it doesn't have the implementation. Getting this? So we can create class as an abstract and method as an abstract as well. So in front of method, I'll simply put a keyword called as an abstract. If you cannot write any code for this, simple. Okay, so you can, if you want, you can change the access specifier for these classes. So probably I may want to put it public, private, protected, whatever it can be, that is possible. So if you want, you can make it public. Similarly, if you see, so abstract can be used, this is a keyword, I am talking about the rules now. So abstract is a keyword, can be used for a class and can be used for a methods, it cannot be used for the variables. Getting it? Abstract keyword cannot be used for the variables. Okay, so abstract class, this shape class can contain abstract methods as well as the concrete methods. What do you mean by concrete methods? Concrete method means the methods which contain some body which has some implementation. So I can have a method called as say display method probably. Yeah, so this is a display method. Yeah, just to understand, I'm just writing out the system.out.println display. Okay, so from this you can see that abstract class shape can contain abstract methods as well as concrete methods. Getting it? Concrete methods means the methods which contain some implementation which has open close this curly braces, right? So we don't have any curly braces here for this abstract method. It has closed because we cannot write the code for this abstract method called as an calculate area. I hope that's clear now. So how do I implement this? So in future I know that we have many shapes which are derived from this shape class, right? We have a shape called as a circle, we have a shape called as an square, we have rectangle and so on, right? Hexagon. Yeah. So from this, let me derive a one more class or one more shape called as a circle shape. So I'll create a one more class, a new class inside the same source called as a circle. Okay, so this is a circle class, and as we already know that circle is a part of shape, it is nothing but a shape, right? So as we already have some of the concrete methods or generic methods here, we have a generic methods written inside this class. This is the basemost class, right? So circle is derived from shape. Can I say like this? Yes, we can say like this because circle is definitely derived from a shape. So I can extend, I can use the extend keyword. We have already seen how to use inheritance concept. So to inherit this circle class from a shape class, I'll use extends keyword. Getting it? This is how I can inherit a circle class from a shape class. If you observe, a circle started shouting, it has started giving us some error, a compile time error, right? So it says that you have to unimplement or you have to override the methods which are abstract in the shape class. Getting it? So this is the second rule. The first rule is shape class, abstract class can contain abstract methods as well as the concrete methods, abstract and non-abstract methods as well. It contains both the methods, right? Second thing is you have to implement all the abstract methods in the derived classes. So if you see in circle class, I am extending shape class, I have to override all the abstract methods. So I'll override calculate area method here. Can you see? So there is no any error now. We don't have any error here. So I have overridden calculate area method, right? Can you see this annotation? This is called as an annotation. This is just an information which says that this method is an overridden method. We already know the meaning of overriding now. Yeah, this is a part of polymorphism. So we have a calculate area method written in shape class, yes, as well as in a circle class. So can I implement this calculate area now in circle class? Yes, we can implement this because we know the formula to calculate an area of a circle. Fine with this? As we already know the formula to calculate an area of a circle. Previously we didn't know that, right? We didn't know how to calculate an area of a shape, right? So now we can calculate an area of a shape. So I can write a code here if you want. So I can say that, so this is 3.14 r into r. So probably what I'll do, I'll just take a radius in the in a constructor. So I'll write down I'll put the constructor here, circle constructor, and I'll take a radius of type integer. Okay, let me initialize this. I'll create a global variable as well. Okay, and let me initialize this dot r equal to r. Okay, this is how we initialize, right? Now, so that r is an radius, so I need to pass an radius to the circle class. So what we'll do now, we can calculate an area. So I will catch it in a float type because the result what we are gonna get is in floats, right? So this is 3.14 into r into r. That r, or that variable r, that is radius, we are going to catch here in the constructor, and we need to pass it in the constructor of this class, right, while creating an object. Okay, we will pass that. So, while declaring and float variables, I need to use an f in front of that. Okay, this says that this is an floating variable. 3.14 is an floating variable, right. Float can catch float and integer as well. These are integer variables, that is fine, because float is the biggest one. So, float can catch float as well as integers. So, that is absolutely fine. Okay. Now, let me just display this area. So, I can say area of circle is, concatenate and print the value of this variable area. This is how I can write down the code. Okay. So, the important thing is to tell here, we have a abstract method, that is calculate area, and as well as I inherit this class, I am using this class, right. Circle class inherits this shape class, extend this shape class. So, if it extends shape class and this is an abstract class, so circle class has to override all the abstract methods. Okay. So, inheriting class has to override all the abstract methods. So, calculate area method is been overridden here. Okay. So, this is the important rule. This method has to be overridden. Remember this. What about this concrete method display? So, it is up to you that you may override it or you may not, right. This is just a normal method, this is just a concrete method. So, if you want, you can override it, if you do not want, you do not have to override this, right. I will come back to circle class. Okay. Now, I will just go to main and I will just give a call to this calculate area method. It is very simple. I have a main here, yes, and to give a call, I will create an object of circle, something like this. Circle, say C is equal to new circle, and I need to pass an radius, say radius is as in 10, and yes, once we created the object, we can give a call to the methods. Can you see that? I can call calculate area method now. Let me run, and on console we can see the output. It says that area of a circle is 314. Yeah. So, let me show you the flow. We have created an object of circle. So, this statement will give a call to the circle constructor. So, it will jump to circle constructor here, right. So, value will get initialized. So, this r is equal to 10 now, yeah, because we have passed 10, and we are calling this method calculate area method. Can you see C dot calculate area? So, it always gives the call to the overridden methods, right. So, in circle class, so it will give a call to the calculate area method, and this will get executed and it is printing the output. That is it. Simple, isn't it? Okay. So, the important thing is to understand the concept of abstract classes. What is abstract class and why abstract class? Okay. So, let me talk about the rules again. So, to talk about the rules for creating an abstract class, we need to use an abstract keyword in front of the abstract class, right. So, abstract can be used for the classes, can be used for the methods as well. So, if you are creating abstract method, it has to end with a semicolon. Abstract class, so the second rule is abstract class can contain abstract as well as concrete method. Fine, this is the second thing. Third thing is abstract method has to be overridden. So, this is an abstract method, that is calculate area. So, once I use this class or extend this class, I have to override this method. So, if I come back to circle class, I have overridden this calculate area method. You have to override this, it is must, right, otherwise this circle class will give you compile time error. Fine, that is the third thing. Next is even if you have a single abstract method, as you can see, I have removed abstract keyword from this shape class. Okay. So, even if you have a single abstract method, as we have here calculate area as an abstract method, you have to create a class as an abstract. A class must be abstract if it contains an abstract methods. Getting it? So if even if you have a single method as an abstract method, I have to create a class as an abstract. This is must. Next is, if you have an abstract class, that is fine even if you don't have any abstract method inside that. Are you getting this? So abstract class can contain all the concrete methods. I am commenting this. So this means what? We don't have any abstract method in the shape class now. I just have a one concrete method. So this means abstract class can contain all concrete methods. So this is fine if it doesn't contain any abstract methods. Getting it? Okay. And the second thing is, as we said, recently as we said, if it contains even a single abstract method, if your class contains even a single abstract method, class has to be abstract. Remember these rules, probably you can note down these rules. Okay. And again, yes, the last one is, you cannot instantiate abstract class, that is shape class. So let me try to instantiate, let me try to create an object of this class. We have created an object of circle, which is a derived class, which is a simple concrete class, right? But we cannot create an instance of the abstract classes, that is in base classes. So I have a class called as an abstract. Can you see that? Abstract demo is an abstract class, and I am trying to create an object of this class now. Okay. Is that possible to create an object of this class? It is not possible to create an object of abstract classes. Instantiation of abstract classes is not possible, right? So if I come back here, shape is an abstract class. So let me try to create an object of shape, not the abstract demo, my mistake. So let me change this to shape. Yeah, now it should not allow. Is that? So can you see that? Cannot instantiate the type shape, because shape is an abstract class. You cannot directly access the abstract classes, right? Because this is conceptual. So it is not possible to create an object of the abstract classes. Fine. So if you want, you can create an references of the abstract classes, that's also fine. Okay. So it's not possible, I'll just comment this. That's it, and we are done with the abstract classes and this rules of the abstract classes. Just remember the rules. Yeah. Let me proceed ahead, and we'll be talking about interfaces now. Okay. So I'll come back to PPT. Let's understand interfaces. So it is a very important thing to understand, why should we go for interfaces if we have an abstract classes, and when should I think of creating an interfaces, yeah, if I have an abstract classes, right? So abstract class says that if you have something imaginary, something conceptual, create an abstract class for that. Same like shape class, employee class, vehicle class. So when should I create an interfaces? Let's understand when should I go for interfaces. Okay. So the very first thing is to remember that interfaces is not like a class. It is not an abstract class even, right? There is a difference between abstract classes and interfaces, and it is a very big difference. We have a very big difference between the abstract classes and the interfaces. Let's understand what is interfaces first. Okay. So basically, if you see, interfaces are mainly used for loosely coupling. So let me note down these. Let me note down these points. So we are talking about interfaces. So when I say interfaces, when should I go for interfaces? Interfaces are mainly used for loosely coupling. Right? So what do you mean by loosely coupling now? What do you mean by loosely coupling? So let's understand the meaning of coupling first. To explain loosely coupling concept, let me open Paint. we'll understand some different hierarchies, we'll understand some scenario here, because this is very important to understand why should we go for interfaces. Yeah, so let me draw some hierarchies here. So to start with, say I have a hierarchy of vehicle classes, vehicle type family, vehicle hierarchy, that is vehicle, two-wheeler and four-wheeler. Similarly, let me complete this first. So this is vehicle. From vehicle, what we have derived classes are four-wheeler and two-wheeler. Right. So these are the two derived classes we have from a vehicle class, and just assume that these are upward facing arrows. Okay, as it is inheritance, we have to show the upward facing arrows. This is an inheritance, right? Okay, so this is a one scenario or a one family. Now if I say can I add a developer class under vehicle? Understand this question. I am saying, can I add developer class under vehicle? Is that possible? Can I add a developer class under vehicle? Right? Probably you may say yes. Yeah, but does it make any sense? If I add or if I derive a developer from vehicle, do you have any common functionalities which vehicle has? No, the developer will not contain move method, developer will not contain accelerate method, right? Getting it? So we don't have any common methods, common functionalities in the developer class. So I'll not put this developer class inside vehicle. Developer will have calculate salary, find out salary, complete the responsibility, maybe something like these methods. But there is no any relation between vehicle and developer, right? So I will not derive this developer class from a vehicle class. Getting it? It's not possible, right? So I'll now derive this. So let me remove this. I'll undo this. I'll just put a mark cut on this. Okay, so this is not possible, right? Okay, and hence we are calling this family or this type as an, so we are calling this as a tightly coupled application. We are calling this as a tightly coupled application because this can only and only include a vehicle type. It cannot include anything other than the vehicle type, right? So from vehicle we have four-wheeler, two-wheeler, n-wheeler, right? From four-wheeler we have Jaguar, we have Audi, we have and so on, Tata, we have Mahindra and so on, right? But we cannot add employees, developer, trainer here. Yeah. So this type of application are called as a tightly coupled application. This is a one type, that is a vehicle type. I cannot add anything different type here. This is very specific to a vehicle type. Are you getting this? So this is called as an tightly coupled applications. Yeah, I cannot add anything different. Fine. So these are called as an tightly coupled applications. So whenever you deal with the tightly coupled applications, try to create a base most class as any abstract class. So in this scenario, our vehicle class will be an abstract class. Okay. So abstract classes are used for a tightly coupled application. Okay. So now let's see what is loosely coupled application. So this is a one scenario, this is a one family of vehicle family. Similarly, we have a different family, say something like this. Say now family of employee. So if I am saying family of employee, again say employee class and developer and say tester. Okay. I am saying employee and what I have is developer and tester. Fine. These classes are derived from employee class. Okay. And now we are saying that this is a one family, that is an employee family, this is again a different type, this is again a different family, right? Oh yeah, it's again a tightly coupled. Can I add vehicle under this? Can I add four-wheeler under this? I cannot add four-wheeler under this. Okay, so this is a different family and this vehicle is a different family. Okay, so in this scenario I can create employee as an abstract class again. So I can make this class as an abstract. Fine. Okay, but these are two different hierarchies or two different families, are very related to each other. So four-wheeler, two-wheeler are related to vehicle, developer and tester are related to employee. Different families, yes, yes, okay. But you may feel that I have to join these two families. I have to combine these two different type of applications by somehow, because they have some common functionalities. Let's assume that I need a print method everywhere now. I need a print method. Okay? Say probably it may print so top speed of this four-wheeler. Okay, it contains some code. So I have a print method in four-wheeler. Similarly, I have a print method here in this two-wheeler. Let me write it down here as well. So I may have a print method here as well in two-wheeler, right? So that means what? I have a print method here in the base class as well, that is in the vehicle class. Okay. Similarly, assume that I may need a print method here in the developer class to print the responsibilities or to print the details of developer. Okay, print method to display the details of developer. Yes, even in tester I have a print method, okay, to print the responsibilities of a tester, to display the details of the tester. So I have to add a print method here as well. So common, so this is a common, so that will be definitely there in the base class as well. Okay. If you observe here, even if there are two different families, two different hierarchies, we have something common in these two, that is print method is used in four-wheeler, print method is used in two-wheeler, print is used developer, and print is used in the tester class as well. So even if they are two different families, we have something common in two different families, right? In that scenario, I cannot create a new class above this. Getting it? So to combine two different families, to combine two different hierarchies, I will go for interfaces, and this is what we call as an loosely coupling applications. So this is so the classes which I have showed in the red circle, red ellipse probably are called as an tightly coupled. So this is tightly coupled hierarchy vehicle, and this is tightly coupled hierarchy, that is employee, because we cannot add any different type of classes under this. It contains only employee type and this contains only vehicle types. So I am calling it as an tightly coupled. But if you see, I need something, as I have something common in between these two hierarchies, I have to add one more class above this. I have to add something above this, and what is that something? Is an interface. Okay. So to couple two different type of applications or two different type of families, what I need is a interface above this. Fine. So interfaces are used for a tightly coupled applications, for a loosely coupled application. My mistake. Assume these are arrows. So these are upward facing arrows. I am very bad in drawing. Yeah. So these are upward facing arrows, and this is an interface. So let me write down the interface called as a printable interface. Okay, and it is an interface. Now I'll just put a I here so that we can understand that it is an interface. Yes, so the interfaces are used for coupling a different hierarchies, a different families. So this is for a loosely coupling, right? Two different families, and in a same family, to combine this, I'll use the abstract classes. Okay, so abstract classes are for tightly coupled applications, and interfaces are for loosely coupled applications. I hope that's clear now. So that's the first use, that is loosely coupling. Second use of an abstract classes, you can say of the interfaces, you can say that interfaces are called as an contract. We call interfaces as an contract. Why we are saying interfaces are something like contract is because all methods in interfaces are abstract by default. I'll just note it down. All methods are default abstract. Okay, so this means what? I can only and only write abstract methods inside the interfaces. I cannot have the concrete methods inside the interfaces. Clear with this? So if you can have only and only abstract methods inside interfaces, that means what? I have to implement all the methods. So we already know that abstract methods has to be implemented, right? So as we are saying, abstract methods has to be implemented. So if I have all the abstract methods in the interfaces, that means what? I have to implement everything, right? So assume that if this printable method or this printable interface, yes, so it should contain method called as an print, right? So for now it contains a method called as an print. Okay, and yes, definitely it is by default an abstract method, public and abstract method. Okay, so has to be implemented. We are saying it is contract. So if it is a contract, that means what? Everything should be implemented, right? It is something like an agreement. We call interfaces are as an agreement, right? So agreement means what? We sign some agreements, right? We know some of the agreements, right? So probably if we are staying on a rent, if we are the tenant, then we have to sign some agreement. We have to make some agreement between the owner and us, right? So why we are making that agreement and why we are signing that? Because we are okay with the rules which are defined in that agreement. Okay, we are okay with the rules which are defined in that agreement. So interface is something like defining some rules, setting up some rules, setting up some standards, right? So we have set some standards. So we have added some standards inside the interface called as a printable, that is print. This is a one standard, this is a one method which is added in this interface. So now if you are using this printable interface, I am using this in vehicle, we are using this in employee. So if you are using this, because of contract, you have to implement all the methods. It is a contract, it is a rule. Getting it? So if you are overriding all the methods, that means you are following all the contract, you are following all the rules. I hope that's clear. Okay, so unlike abstract classes can contain abstract as well as non-abstract, but interfaces contains all the abstract methods. So this is the difference between abstract classes and interfaces as well. Fine. So that's why we are saying interfaces are something like a contract. Okay, so whenever you have to define a contract, whenever you have to set up some standard, whenever you have to set up some rules, some protocol, go for an interfaces. Don't use the abstract classes in that scenario. Third use of interfaces, you can say interfaces can be used for definitely a multiple inheritance. Okay, interfaces are for multiple inheritance. Fine, and this is not to multiple inheritance to get the direct multiple inheritance. This is to achieve the multiple inheritance. This is not an actual inheritance, it is just an illusion. Okay, we cannot have a multiple inheritance in Java. Remember this, Java doesn't support multiple inheritance, but just to achieve, just to make a feel, yeah, just to achieve, we can use interfaces in that scenario. So interfaces, so this means what? Multiple inheritance means what? So you can implement as many interfaces as you want for a class. Okay, so for now I am implementing printable interface for vehicle and printable interface for employee. So this is a simple inheritance, right? A single inheritance. If you want, you can implement more than one interface as well. Getting it? Okay. So I may have a interface called as an, say, demo interface. Assume I have an interface called as a demo interface. This is an interface, okay. Just put I in front of this, say demo interface. If I am creating demo interface, yeah, again this class can implement more than one interface. This is again a upward facing arrow. Assume this is an upward facing arrow, okay. Fine. So one class can implement more than one interface. So this vehicle class can implement demo interface, a printable interface, clonable interface, serializable interface, as many interfaces as it can. Okay. So it looks like a multiple inheritance, right? So to achieve multiple inheritance, we can make use of interfaces. Fine. So I hope the rules and the need of interfaces is clear. Let's directly go for a demo now, and definitely we'll see some rules as well. We'll make a note of rules as well side by side. Okay. So I'll come back to Eclipse now. Let me come back to Eclipse and let me create a demo for interface. I'll create a new Java project, say interface demo. Spare me if I am making any spelling mistakes. I will create a package com.psl.set demo again. Okay, we are creating a class called as an interface demo. Okay, I have a public static void main in this. Okay, so let me create some interface now. So interface called as an printable interface. Same like a class, we can create an interface by saying new. As till now we have created a class. This C here in a green color stands for class, and this I here stands for an interfaces. So same like class, I can select this interface. Yeah, we wanted to create it in the same package, and I can give a name to some interface. Okay, so I can say printable interface. So we are just creating interface called as a printable interface. Okay, and this printable interface contains a method called as an print. Yeah, so let's talk about the rules as well. So this is how I can create a simple interface. Okay, this is a simple printable interface. So interfaces are created with the keyword called as an interface keyword. Okay, so same like a class, I'll just remove that class and I'll just replace that class with an interface. So interface keyword is used to create an interface. Okay, then interface can contain only and only public and abstract methods. These methods are public and abstract, right, and they are by default. Okay, so let me make a note of the of rules for this interfaces. So the first thing is interfaces are for loosely coupling. We are making already some of the notes. So all the methods are by default public and abstract. Okay, remember this, all the methods inside interface are by default public and abstract. We cannot create a concrete methods inside the interface. So even if you write these keywords, or if you don't write, that's all, that's fine, that will work. Okay, the methods are by default public as well as abstract. So if you write, or if it doesn't write, that's fine. They are by default public and abstract. Okay, and we are saying it cannot contain concrete methods. So let me show you. We cannot have concrete methods. Concrete methods means which has some implementation, yeah, which has some definition, opening the closing and opening and closing braces here. So that means concrete methods. So can I write concrete methods? We cannot. It has started giving us some error. Abstract methods do not specify a body. Can you see that? Right. So we cannot have a concrete methods inside the interface. Yeah. So we can write only and only public and abstract methods inside the interface. This is the first rule. Okay. How about the variables? We can create variables inside this interface. How we can create? It is something like this. Say assume integer variable a is equal to say 10. I am creating a variable, and this variable is by default public, static and final. I will just scroll on this. Can you see this word keyword code as an S and F here? This word S and F, that stands for static and final. Okay. So variables in interfaces are by default public, static and final. Okay. The variables are by default public, static and final. So even if I don't write these keywords in front of this, that will also work. Okay. And we already know the meaning of static, final and public, right. So why they are by default public? Because it is for multiple inheritance. This is for loosely coupling applications, right. So it may, you may use the interfaces anywhere. You may use the interfaces anywhere in different packages. So one type contains, or one family is in one package, different family is in different package. Package is for differentiating the families, differentiating the types of the classes, right. And as interfaces can be used in any type of package, anywhere, in different hierarchies as well, right. This is for loosely coupling. That is why methods inside these interfaces are default public. Okay. They are by default public. Okay. The variables are by default public, static and final. Remember this. This is the second thing. I can make a note here if you want. Variables are by default public, static and final. Okay. Yes. So let us proceed ahead and let me implement this interface now. Let us see how to use this interface. So we have just created this interface. Let me see how to implement, how we can implement this interface. Assume we are creating a class. Let me create a class now. Say class called as an, assume we have a hierarchy and we have a one derived class called as an four-wheeler. Okay, we have a class called as an four-wheeler. So and so can you see we have interface demo, four-wheeler and printable interface. So I wanted to make use of this printable interface. So how we can use printable interface? Interfaces are implemented. So to use interfaces, I will use a keyword called as an implements. I will not use extends now. So classes are extended, interfaces are implemented. That is what we say. Okay. Remember this, classes are extended, interfaces are implemented. So we use implements keyword to use or to implement an interface, right. So we are saying implements, right, because it is just a body, it is just a structure, it is just a standard. It is just a structure means because we do not have any body here, it is just a structure, it is just a body, it is just empty. So we have to implement it for first time. That is why we have a keyword called as an implements and not extends. Extends is for inheritance, extends is for classes, extends is for abstract classes, right. So implements is for interfaces, remember this. So once you say implement interface, it gives us error. It started shouting again. So what it says? you have to implement all the methods. Yes, we said it is a contract, right? It is a contract. So what do you mean by contract? Contract means you have to implement all the methods. You have to implement all the methods present in this printable interface, right? That's why we are calling this interface as a contract. Okay. So once you override that print method, so we have a print method in this printable, yes, and that is by default public and abstract. Even if I remove this, that doesn't matter. And in four-wheeler, I am implementing this printable interface, right? And if you implement that interface, you have to override all the methods. So I have overridden this print method. So now I can write down the code inside this. I'll just put a simple sys out here saying that this is a print method from say four-wheeler. This is a four-wheeler print method. Okay, that's it. So the third rule, fourth rule, whatever it is, it says that once you implement interface, you have to override all the methods. Remember. Let me come back to the main now. Let me see. Let me show you how we can give a call to interfaces and how we can give a call to the implemented interfaces. Yeah. So same like abstract classes, interfaces cannot be instantiated. We cannot create an object of interface. So I cannot create object of interface. I'll just show you. Okay, is it possible to create an object of interface? We create object by saying new. Yeah, we have a printable interface. Is that possible? Is that allowing us? It is not allowing us. It is giving us error. Cannot instantiate the type printable because it is an interface. Okay, so it's not possible to create an object of interfaces, and even for the abstract classes, it is not possible. But you can create the references. That's possible. You can create a reference of the interfaces or a abstract class as well. So references is possible, but for instantiating an object is of derived type, yeah, or a concrete class. Okay, so we can create an object of four-wheeler here. Can you see this? So it is something like base type reference. Yeah, reference is of type interface, reference is of type abstract class, it's possible, and object of derived class. Yeah, implementing class. So in implementing class, this is implementing class, right? In four-wheeler, we have implemented that printable interface. Yeah, so this is possible, and now I can call a methods on this obj, and the method is print method. Can you see that? Print method from four-wheeler. It's that simple. Just understand this concept. Interfaces are for loosely coupled applications. Interfaces are a contract. Interfaces are mainly used for the loosely coupling. Okay, loosely coupling, it is like a contract, and it is for a multiple inheritance as well. Let me show you for a multiple inheritance. Yeah, so Java doesn't support multiple inheritance. That means what? We cannot extend more than one class. Okay, one class can extend only one class at a time, but it can implement more than one interface. Okay, we have created interface printable. Let me create a one more interface. Let me create a one more interface. Say demo interface. We have an interface called as a demo interface. Okay, and this has a method called as an say display. Okay, demo interface method has a display method. It is by default public and abstract. So now we have two interfaces, demo interface and printable interface. So I can implement it Yeah, so I can implement more than one interface. Yes, that is possible, and that is simply by giving a comma. Yes, implements printable comma demo interface. It is possible. Okay, the only thing we need to remember is you have to implement all the methods from printable and all the methods you have to override from a demo interface as well. So let me implement that. Can you see we have a display method in yes, we give a closing for this. Yeah, so can you see that we have a display method in demo interface, okay, and we have a display method here, define display method, and we are overriding that in a four-wheeler, okay, and I can use system.out.println here just to give some implementation. This is display from four-wheeler. That's it. So we can achieve multiple inheritance. It is just an illusion, it looks like a multiple inheritance. Okay, so to achieve multiple inheritance we can use the interfaces. Yeah, so it can implement more than one interface, as you can see here. That's all. We're done with the interfaces. I hope that's clear now. Okay guys, so till now we have seen how to work with the abstract classes and the interfaces, and we have seen the difference between abstract classes and interfaces as well. That's then one of the important concept which we have covered, and we have seen as well as the rules in abstract classes and interfaces. Yeah, and we have seen the demo, and that is and how to implement abstract class and how to implement an interface as well. Okay, so in continuation with that, we'll start with a new topic, that is an exception handling now. Okay, this is completely a new topic, and believe me, this is again a very important concept, and this is very nice to understand. Yeah, this is very beautiful. Let's start with the exception handling then. Yeah, so to start with exception handling, so our main objective is to go through what is exception first. Yeah, so we'll understand what is exception and how to handle the exceptions, right. Then we'll understand the difference between exception and error, what is an actual difference between exception and what do you mean by error. Yeah, then we'll see what we have in Java to handle the exception, that is exception handling framework. Yeah, and when then we'll see the types of exception, that is an difference between checked exception and unchecked exception at the end. Yeah, and finally we'll have a hands on. Yeah, we'll see how to handle the exceptions, we'll see it in the Eclipse, yeah, by using try, catch and finally block. So to start with this exception handling, let's understand what is exception first. Okay, so when I say what exception, so exception, the very first thing is to understand exception is not a error. Error is completely different and exception is completely different. So error is a one thing, so we are talking in Java domain now. So these are the terms are defined in a Java now. Okay, so in case of programming language, rather I can say in software domain, exceptions and error are defined as, error is something which cannot be solved. Okay, so when we can say anything as an error or any problem as an error, so if you don't have any solution for the problem, then we'll call it as an error. Okay, so if you don't have any solution, then we'll call it as an error. That can be the syntax error, yes, so which cannot be solved. You can solve it, but that is a syntax error, right? So the problem which occurs at runtime, we are talking about runtime now. So while executing your program, while running your application, in the deployment, after deploying your application, if any problem occurs, any exception occurs, and if you face any issue, and if you are not able to solve that problem, if you are not able to solve that issue, then we will call it as an error. If you don't have any solution, then that is an error. Okay, so what is an exception then? So exception is something which the unexpected condition that occurs at runtime. Okay, this is nothing but an unexpected condition which occurs at runtime, but which can be solved, which has some handling, which has some mechanism to solve that problem. Okay, so this is nothing but some problem occurred at runtime, but which can be solved. Simple as that. Okay, a problem occurred at runtime which can be solved is nothing but the exception. So in short, you can say it is an so we can use the exception to avoid the abnormal termination. Okay, this is just to avoid the abnormal termination. So how do we handle the exceptions? So that can be handled programmatically. We have a very rich library for this in Java, that is an exception classes, that is an exception hierarchy, exception framework. So we'll talk about that little later. So this is very simple to work with exception in case of Java, because we have inbuilt classes, the libraries provided by Java directly. Fine. And yes, because of this exception, Java becomes very powerful, Java becomes very robust, right? Okay. So just to understand what is exception, let's take a scenario. Yeah, when should I use exception handling, and why should I use exception handling? First of all, assume we'll take an example of, say, ATM machine, right? We all are worked with the, or we all have we have already accessed the ATM machine, or we have already withdrawn some money from ATM machine. So we'll take an example of ATM machine. Assume we have not used exception handling while developing a software for this ATM machine. Okay, it is already deployed and it is running. So ATM machine functionality is to withdraw money, probably. Yeah, this is the first functionality, the basic functionality, right? So so ATM machine shows a welcome screen first. Its flow is something like welcome screen, and then it will ask you for the insert the card, and then the machine will ask you for the enter the PIN number, probably. Yeah, this is the common flow. And after entering the PIN number, after validation, it will ask you to enter the amount, and it will check with the balance, and then it will dispense the amount. Yeah, so this is how you can withdraw money. But the problem is that, assume you have entered the amount, enter the PIN number, everything is correct. Yeah, you have a sufficient amount in your balance in your account. Yes, and suddenly we got a reset saying that the money is withdrawn. Say you have entered 10,000 rupees, so money 10,000 is been debited, and you didn't get the money, you didn't get the cash actual. Yeah, so amount has been not dispensed, but you are getting just a receipt saying that amount has been debited from your account, right? And it has started, suddenly it has started showing that a blue screen, maybe an error, a sudden shutdown in between. So we'll get panic and we'll say that, dude, what has happened? Amount has been not dispensed, and it is saying that amount has been debited from the account, right? So this means in some of the scenarios the problem or exception is not handled, right? So we have, there is some exception, there is some problem occurred in between the transaction, maybe because of the network, maybe because of the low bandwidth, maybe because of the server shutdown, can be anything, right? So that can be anything. So maybe the sufficient amount is not there in the account, maybe because of that, right? But we'll not understand what was the actual problem, right? There is a sudden shutdown. Because of that sudden shutdown, we got a panic, and we have, so it is better to tell a user at least we should give a user friendly message to a user, I mean to say. Okay, so at least we should say, so ATM machine should display that the amount is been withdrawn from your account, there is some issue with the transaction, so will be deposit will revert your amount in half an hour. Yeah, if you get that message on a screen, maybe will relax, right? So amount has been withdrawn, but there were some of the problem with the transaction, it has not completed in a one go, because of that probably there was some problem and will be deposited in account again in half an hour. Yeah, so this is very important to handle the exceptions, right? So exception is something which you should handle in every program, in all the program, right? So whenever we write a business logic, I'm talking about business logic now. Whenever we write a business logic, whenever we have a code where we feel that we may have some different scenarios, where we may have a different problems may occur in this scenario, right? So if you say, is there anything, can I say everything is perfect in this world? No, we cannot say that, right? There are some issues, there are some problems, we'll always get some problems, we'll always get some issues while executing, even before executing, right? So to make it sure that it will work at least perfect, or at least to the extent, at least to the good extent, to the perfect extent, yeah. So we should try to we should make sure that we should put our code inside the try catch block, right? So if I put it inside try catch, if I try to handle the exception, it will at least try to give a user friendly message to the user, right? So we'll use exception handling basically to handle the exceptions, to handle the problems, to avoid the abnormal termination, so that the machine should show, or as we are taking ATM machine, so machine should say that money is been, there is some issue with the backend, will deposit your machine, will deposit your amount in half an hour, and it should show a welcome screen again. There should not be a sudden shutdown, right? So this is at least to handle the problem or to show a user friendly message, simple as that. Okay, yes. So how do we use it and how do we handle it in case of Java? So it's very simple. In case of Java, what we have is a try, catch, and finally blocks. We have a try catch block, right? And try catch are nothing but the keywords here. So as I'm saying, these are the blocks, these are not methods, right? Methods can also be called as a block, but inside a block is something which contains some statements, right? Which we can write it anywhere, right? Which we can call it as a block. So by using try catch block, we can handle the exceptions. So we should write a code inside try, where we may feel that we can get some problem, we may get a issue in execution. That code should be written inside the try, and the solution for the problem should be written inside the catch block. Okay, so catch handles the exception that is thrown in a try block. Yes, we'll talk about finally little later, but for now just understand that finally block holds the statements that must be executed. It says that the finally block holds the statements that must be executed irrespective of exception is thrown or not thrown. Okay, so finally block gets executed always, whether you have an exception, whether you don't have an exception, finally block is executed always. Yeah, so we'll talk about that, we'll talk about finally little later. So once we go to Eclipse, once we have a hands-on on this, we'll talk about finally again, right? So for now just understand that try is to handle, try is a block, so inside try we'll write down the code. Yeah, so maybe where you may feel that there can be exception, there can be a issue, we'll put that code inside try, and the solution for that problem we'll put it inside a catch. Yes, okay. So this is a basic hierarchy of an exception classes what we have in Java. So in case of Java, this is an hierarchy of exception classes we have. So let's understand what is this hierarchy. Yeah, so the basemost class in case of Java, and all these classes interfaces are present in java.lang package, that is a default package. Okay, these are directly present in a java.lang package, so we don't need to import any different package as such. These are present in a java.lang default package. Fine. So let's talk about this. So what we have is a basemost class called as a throwable class. As you can see in the on a PPT, it is a throwable class which is an basemost class, right? So from throwable we have two types of classes. that is error class and the exception class, right? We have error and the exception. We know the difference between error and exception now. Error which occurred at runtime but cannot be solved, which doesn't have any solution, we'll call it as an error. Exception which occurs at runtime but has some solution which can be solved is an exception. Simple. Okay, so we'll talk about exception now. So on right hand side, if you see, exception is again divided into the two parts, that is IO exception and runtime exception. IO exception and runtime exception. We also call it as unchecked exception and unchecked exception. So IO exception is also called as an checked exception. Okay, so IO exception is also called as an checked exception. Runtime exceptions are also called as an unchecked exception. Remember this. Okay, and we can also call it as an IO exception are also called as an compile time exception and runtime, and yes, this is a runtime exception by default. Okay, so IO exceptions can be called as an compile time exception or unchecked or a checked exception. Okay, IO exception, compile time exception or checked exception. A runtime, so in case of runtime, this is runtime exception or unchecked exception. Okay, and these are some of the examples. So file not found exception is an IO exception, right? File not found, class not found, yes, these are the exception which falls under the IO exception. Yeah, we call it as an checked exception as well. And in case of runtime exception, some of the examples are array index out of bounds exception, number format exception and null pointer exception. This comes under runtime exception. In case of error, if you see a virtual machine error, out of memory error, network shutdown error, right? So these are the problems which we cannot handle, right? Which may occur at runtime because of the hardware issue maybe. So out of memory is because of the limited configuration, right? We cannot do anything for that, right? And which cannot be handled. So this falls under error. Okay, so stack overflow is again again an error. Okay, so if you don't have any solution, that is an error. If you have a solution at runtime, that is an exception. Okay, just to understand this, let's differentiate error, checked exception and unchecked exception now. Okay, that is error, IO exception and runtime exception. Let's differentiate these three things. Okay, let me take an example. Say a group of team is planning for a trip. Okay, some group of team are planning for a trip, right? In a group, say there are 100 people, yes, 100 people in the group, and out of 100 people, some of them are 70% are saying let's go to Goa, and some people are saying let's go to say Manali. Yeah, so before execution there is some problem. Some people wanted to go, there is a team, they are planning for a trip. Yeah, they are just planning for a trip, and in between while planning even they have a problem. While planning, some people are saying that let's go to Goa and some people are saying that let's go to Manali, right? So there is a problem. Yeah, it has occurred, we can call it as a problem, right? So it has occurred even before the execution. Yes, can we solve this? Yeah, we can solve this issue, right? So before execution some problem has occurred but we can solve it, so that comes under checked exception or a IO exception. Remember this, a problem occurred before execution but can be solved. Problem occurred before execution but which can be solved is called as an IO exception or a compile time exception. So how do we solve this? So either we'll convince everyone to come to Goa, yes, or we'll get convinced to go to Manali, right? So we have a solution for this, right? So this is what a checked exception is. Yes. Yes, what can be a runtime exception? So any problem occurred at runtime, if I consider the same example, say so everyone is assume that everyone is convinced to Goa, to plan a trip to Goa, right? So everything going smooth now, everyone is ready, so we have headed towards Goa. Yeah, so while going Goa they face some problem, maybe tire got punctured, right? They face some problem a tire got punctured, right? So while execution we got some problem. Can we solve this? Yes, they have a a spare tire with them, right? So we can change that tire. A stepney we have, right? So they have that stepney, they have changed that tire, and the problem is solved. A problem occurred at runtime, but which can be solved, is a runtime exception, right? Or a unchecked exception we also call it as, right? Yes. What is an error? Error is something which cannot be solved. Now in the same example, we can say, yeah, team has planned for Goa, but there is curfew in Goa, for which we cannot do anything, right? Or maybe because of the natural disasters. Yes, we cannot do anything, right? Maybe an earthquake has occurred in Goa, because of that Goa is closed. Assume, we are just assuming this, yeah. So that's an error, right? So some problems which we cannot solve are errors, yes, and the problems which occurred before the execution are IO exceptions or checked exceptions. Checked, name itself says checked, before, right, compiled, yeah, and unchecked, which are not checked, which will occur at runtime, right? Okay, I hope that's clear now. So you know the difference between checked, unchecked and error now. Let's proceed, and we'll see a demo now directly. I'll go to Eclipse. Let me close all of these. Yeah. I'm creating a new project every time just to avoid a confusion. Let me create a new Java project. Yeah. So we'll create an exception demo, right? I'll create a new class, insert some package, com.psl.say demo. Say this is exception demo. Let me correct this. Exception demo. Yes. I'll rename it. Yeah. I have a public static void main in the same class. Let me maximize this. Okay. Let's talk about a divide by 0 problem first, yeah, which is an runtime exception, unchecked exception. We are talking about unchecked exceptions for now, okay. So assume we have two numbers, right? So we are talking about dividing a number, okay. So we have two numbers, say A is equal to 10, I am initializing the values as well, and B is equal to 5. Similarly, we have one more variable called as an result. We'll catch and we'll initialize it to 0. We'll catch our result in result variable, okay. So what we are trying to do here is we are trying to calculate division of A and B. We'll try to find out the division of A and B, okay. We'll divide A by B, fine. We'll catch it in the result, right. Assume this value of A and B are taken from user, just assume that, okay. So this is a system where the value for A and B are entered by user, yeah, just assume that. We are hard coding the values for now. Just assume these values are coming from user, and let me print the output on system.out.println, saying that result is result or division is result. So we are not using any try catch block as of now. We are not handling any exceptions as of now, right? This is just a simple program as we have done till now, as we are doing till now, right? Let me execute this. Do you find any problem, any issue here? No any issue, no any problem. This will execute and the result is 2. So definitely if I divide 10 by 5, I'll get a answer as 2. Assume as it is we have a user interaction here, a number B a user has entered as a 0, a value for, so for the dividend, now the dividend is 0, right. So, if I divide, if we already know that if we divide any number by 0, so it is divide by 0 error, right. So, we cannot divide any number by 0, that is a problem, that is an issue. So, it is a run time, right. So, it is not giving any problem for compile time. I have saved my program. So, there is no any compile time error, no any compile time problem. Now, if I run this, yeah, if I run this, I am getting an arithmetic exception. So, as you can observe in console, it is saying that arithmetic exception divide by 0, right. After that, it is showing some description about that exception and a line number as well. Can you see exception demo.java and 9. So, if I click on this, it will tell it will navigate to that specific exception, wherever that specific exception has occurred, right. So, the exception is occurred on line number 9, right. Okay. So, we got a abnormal termination, it is not printing this value, and let me print one more statement just to understand what is abnormal termination. So, I will say everything say looks good, yeah, proceed ahead, right. Probably we can say everything looks good, proceed ahead, right. Let me execute this and let me see if it prints this statement or no, right. We are dividing some number by 0. So, if I run this, it is not printing that statement, right. So, this is an abnormal termination, a sudden stop, a sudden shutdown, right. Okay. So, this should not happen, right. So, we should handle the exceptions in this scenario. So, whenever you may feel that there is a problem, there is an exception, there can be an exception at runtime, try to put that code. So, I think this statement or this particular code should be written inside try catch block, right. So, I will put such code inside try catch block, okay. So, or you can use it something like this. I am using shortcuts for now. So, I can simply use try and catch, okay, and catch has some parameter, catch has some parameter. So, we have a types of exception, that is what exception will occur. Now, we know the exception type is, this is related to the arithmetics. So, the exception will occur as an arithmetic exception. So, we should write an specific exception in catch all the time, not the base most class, that is an exception, right. So, we should write the specific exception types. So, that is an, so I should say arithmetic exception, right, and the variable for this say AE, that is just an reference or a reference variable, right. So, arithmetic exception will occur, and I just need to put this code, I will just cut and paste it inside try now, okay. This is the best practice, this is an best practice, right. So, we should try to put our code inside try, and a solution for that problem we should put inside catch, right. Variables should be declared outside try, a code, only the code which you may feel that the problem will occur, try to put it inside try, okay. Everything other should be outside try, yes, declaration is outside try, okay. Now, a solution will provide inside try. So, what will happen? Exception will occur on line number 11 now on this statement, because you are dividing by 0. So, from this statement it will jump to catch, because it is searching for a problem now, this is searching for the solution now. So, we should provide a solution here inside catch, okay. So, I will provide a solution, I will give a sysout, I will print on the console saying that hello, you cannot divide by 0, you cannot divide any number by 0. So, we will just give a sysout, or we will just print it on the device or a screen, you cannot divide by 0, say, right. Okay. I will just give this sys out saying that you cannot divide by 0, and so the user will understand that I should enter some different value for this b. So he will enter some different value. Assume we are taking input from user now. Say assume 2 is been entered, and we calculate the result again. Result is equal to a divided by b again, and we are just printing and result. So this is result is and the output and value of that result. Okay, so this is how we can use try catch block to handle the problems, right? So as you can see, exception will occur on this if number is divided by 0. So from this statement it will jump into catch block, as this is an arithmetic exception, right, that we have to specify in the catch block. It will jump and it will proceed. So we have given a user friendly message saying that you cannot divide by 0. So user has entered some different value, we calculated, and it will print and it will proceed ahead. Now there will not be any sudden shutdown, there will not be any abnormal termination, right? Let me execute. Let's see if it works. Save and run. Oh, so as you can see, it has entered in catch block, right? You cannot divide by 0. Result is been calculated. The value of b is 2. So 10 divided by 2 is 5, and then onwards after catch block we have written everything looks good. So everything looks good, right? So this is how we can use the try catch blocks to handle the exceptions to avoid the abnormal termination, right? So that's how simple it is, isn't it? Okay, so let me tell you what all combinations are possible, right? What all possible combinations for this try catch. So one is try catch, a simple try with a catch, or we can also have a try with a finally, right? We can have a try with multiple catches. Okay, so I can use a one more catch here if I want. So it is not always that we'll have a only arithmetic exception, right? So in this code or in this statements, assume we may get some different exception or we may get a different problem, right? So we should have some different catch for that. So every problem should have a different catch. Remember this. So every problem should have a different catch. So for different problems, number of problems, we cannot have a single solution. For different solution, for different problem, we have a different solutions, right? So hence we can have a number of catch block for a single try. A try can come up with a multiple catches. So I can have a try with a multiple catch as well. So I can write a try with multiple catch, something like this. Try with one catch, try with two catches, try with n catches as well. Okay. Let me talk about null pointer exception for now. Okay. Assume I'll just modify the same code to get the null pointer exception. So we get a null pointer exception if the variable or if the object is not initialized. Okay, if we don't initialize an variable and if we try to call any method on that, if we try to access any member on that object, it will show you null pointer exception. That means object is not initialized, object is pointing to null, right? Then we'll get a null pointer exception. So let me create a scenario for this. What I'll do, I'll create a display method here, simple display method. Okay, a private method. I have a system.out.println in this, and let me try to create an object of this same class to call that display method again. Exception demo obj equal to null. Okay, I'm writing directly, I'm pointing it to null directly. I have not said or I'm not using exception demo obj equal to new exception demo. So this means what? This is not initialized. Object is that not actually created. We just have a reference of that, right? So in case of Java, you should create a complete object. So using new keyword is necessary. Using new keyword is must. Right? This is just a reference. So it is not an creating an object. This is not object, right? Actual object. And if I try to call a method on that, that should give us null pointer exception, because object is pointing to null. Clear with this? Okay. So, let me try this now. So, I'll show you, I'll just show you a flow. Values are entered, object pointing to null, reference pointing to null, object is not created. Inside try obj.display, right, and from this, on this statement it will give you an exception, right, and it will jump to a catch, it will search for a corresponding catch. Do we have here, does this catch contain the solution for handling the null pointer exception? No. So, it will go for next catch, right. So, we have a catch which handles the null pointer exceptions, right. So, from this statement, as the object is not initialized, it will jump to this second catch, right, and we can provide a solution here. I will just provide a solution, I will just put a sys out saying that object is not initialized. Okay. Object is not initialized, so we need to create an object. So, I will say obj equal to new exception demo. This is how we will create an object, and probably we can call the display method again, right. So, it should come inside this. Okay. So, this is an solution. So, let me show you, if I do not have any solution for this, or if I do not have a catch for this, what happens? Yeah, we have a try catch, but we do not have any catch to handle this type of exception. We have a catch to handle arithmetic type of exception. So, we already handled arithmetic exception. So, it will not, there will not be abnormal termination for this, but there will be a problem for this statement, right. So, again abnormal termination will get, because we do not have any catch. I have commented this, I have added this in comment. Okay. So, it should not print this statement, everything looks good, right. Let me run, and let us say if it throws null pointer. Can you see, it says null pointer exception, and the problem is in line number 19. Okay. You cannot call any member of a class if the if object of that class is not initialized. Okay. And hence I have a different catch to handle that. So, it will jump to this catch, and it will print this statement as well. So, let me run. Can you see this? It has entered in a catch, object is not initialized, object is created and method is called, right, display method is called, and everything looks good. This is how we can handle the exception, this is how we can handle the problems in Java. Simple, right? Okay. So, we can have try with a single catch, we can have a try with multiple catch as well. Similarly, we can handle array index bonds, array index out of bound exception, and we can handle probably class not found exception, probably file not found exception, same way, right. We can have number of catches for a single try. Okay. Let us proceed and let me talk about finally block now. Yes. So, a try can also come with a finally block as well. Try with finally, try catch finally, try multiple catch finally. So, I can use it something like this, right, finally block. This is how I can use a finally block here. So, finally can come with the try, only try and finally, try catch finally, try multiple catch finally, all these combinations are fine, right. So, when should I use this finally block? Finally does not have any parameter, right. So, finally is not for handling the exception, it does not handle the exception. Finally is just to execute always. Finally says that whatever is this code or whatever are the statements inside finally, those will get executed all the time, irrespective of exception occurs or exception does not occur, right. So, if I write anything in finally, that will be always executed. So even if you have an abnormal termination, right? So I'll just print something. So finally says that I'll always execute. Okay. Now let me run, let me check. We don't have any exception as of now. We handled the exception. Program is correct, right? Can you see? Object is not initialized and it has entered inside this second catch. I'll always execute finally, and after that everything looks good. Everything looks good. Fine. Now assume we have not handled this exception. So we have abnormal termination now, right? We have abnormal termination. We have not handled null pointer exception. So if you have abnormal termination, this statement will not be printed. But in some of the scenario, assume you may feel that you have handled all the exceptions, but at runtime you don't know what exception will occur, or somehow some exception has occurred or some problem has occurred. But in that scenario, you just have to show an welcome screen all the time, right? Just taken that ATM machine example. While performing some transactions, while performing some operation, if any problem occurs, any issue is there in the operation, you have to come to the welcome screen at the end, right? This is the minimum requirement which you have, right? Even if the amount is not dispensed, it should work for the other one, right? If there is a network shutdown, again it should come back to a welcome screen again, right? It should not suddenly show that a blue screen or error screen. Getting it? So we wanted to perform some operation even we have a problem. Some operation means some statements, some codes should be executed even if you have a problem, right? In that scenario, we'll use a finally block. Finally block always executes even if you have a exception or if you don't have any exception. So as you can see, we have not handled null pointer exception. There is an abnormal termination. This statement 45 highlighted statement is not printed, yes, but still it is executing finally block. So finally blocks executes always irrespective of your exception. Remember this. So what type of code you should write inside finally? So finally should contain maybe a resource closing, right? So these are mainly for the closing the resources, right? So maybe a file closing, file opening, right? We have open file, right? We have streams, open streams, right? We should close those streams inside finally block, right? So you may have a file open, yeah. If that file is open, that will not be accessed. You don't have access to, others cannot access that file, right? If the file is open, yeah, by one user, the same file will not be available for the second user then. So what we should do, yeah, if the exception occurs in between, if that file is opened and any exception has occurred, right, so that file will remain in the open state always, right, and that will not be accessed by the other programs or maybe for the other users. So in that scenario, we should, even if exception occurs, we should close that file, right? So closing the resources type of code we should write inside finally, right? So closing the files, closing the streams, we should put inside finally block, right? So that's how finally block works. And that's it, and we are done with this exception handling. This is just a basic exception handling. Other than this, we have custom exceptions. We have throw and throws as well. Probably you can study that on your own. So for now, we are done with the try catch and the simple exception handling. Okay, so till now we have seen abstract classes and interfaces. After that we have seen exception handling, how to work with the exception, and even we have seen a demo for exception handling, try catch and try catch finally block as well. Let's proceed ahead, and this is our last topic, that is collections and map. And this is one of the very important topic, believe me, this is one of the important topic in Java, right? So let's go through collections and maps. What do you mean by collection? What is an collection API, right? So let's cover this topic. Yeah, so our objective is to understand what is collection and why collection, right? And then we'll see the core interfaces and classes in collection API, right? Then these are the, again, list, set and map, these are the part of the collection interfaces. So we'll talk about list, set and map. These are the core interfaces, right? And once we understand the difference between list, set and map, and we'll implement at least one classes from list, set and map, right? We'll see a demo for list, set and map directly. Okay. So let's understand what is collection first. This is an collection framework. So before looking at this collection framework, let's understand what is collection and why do we understand collection, why do we use collection in Java. Okay, so to talk about collections is a new API or a library, a new collection API or a library completely provided in by a Java people, right? So why do we need this API? Collection, basically it's a set of data, it's a set of objects, right? So collection just stores a data, manipulates a data, right? Nothing else. So this is just to store, manipulate and retrieve. Okay, collection is nothing but just to store, manipulate and retrieve data. Data means object. So in case of Java we deal with the object, so we should say object. Okay, so this is just about manipulating your objects, nothing else. So we manipulate our data or we manipulate our objects in arrays as well. So we know arrays, right? So arrays are again to store different types of, or maybe of the heterogeneous type of data, heterogeneous type of objects in a single variable, right? In a contiguous memory, right? So we have arrays to store more than one data in a single variable of same type, right? Then why should we go for a collection? So even we can manipulate our data in case of arrays. So I can create an array of integers which can have a size as in 10, and I can store 10 integer values in that, and probably I can manipulate it by, or retrieve or store it by the index, array index, right? So why should I go for collections then, is the main important thing. So collections is something which is very easy to work with, because we have additional, this is a complete API, complete new library, right? So if I am saying API, new library, that means they have provided us number of methods in these classes, different types of classes, right? So it becomes very easy to manipulate a data. So we may have a different scenarios. In some of the collection, in some of the scenarios we may want to store a duplicates, we may don't want to store the duplicate values. So in that scenario we will not write a code to create an array which doesn't allow the duplicates data. So rather than writing or wasting our time to create complete new type of array, why not to use which is already been provided, right? So we have collection classes which gives us some ready-made code, some ready-made methods, right? By using those methods, iteration, sorting, searching, right, and manipulating of data becomes very easy with comparison with arrays, right? In case of arrays we don't have any methods as such, we don't have anything to manipulate our data directly, but in case of collections we can easily manage our data, manipulate our data, sort, search, becomes very easy. Okay, so that's why we should go for collections. So let's talk about collection framework now, collection hierarchy, and even we'll talk about the differences in collection. So to start with collection interface, if you see a base most interface here, yeah, I am saying interface, a base most interface here is a collection interface, right? And from collection interface we have mainly 3 derived interfaces. If you observe this diagram, you can see that from collection interface we have 3 interfaces, that is list, set and queue. Fine. So list, set and queue, and we have one more other which has drawn in some square, probably a parallelogram, right? That is not derived from collection interface, that is a map. Map is not a part of collection interface, right? So, list, set and queue are derived from collection interface. So, let us understand the difference between list, set and queue first. List is mainly used for duplicates, okay. So, whenever, so let me note it down so that it becomes very easy to differentiate. I will open notepad again, let me create a new one. Okay, to differentiate between list, set and queue, okay. So, list contains duplicates, okay, list contains duplicates. Find duplicates means, so if I have a input data as in A comma B comma C, the output will be, duplicates are allowed, A, B, C and probably A again or say B again. So, what will be the output? I will always get A comma B comma C comma B. So, this will be the output. Okay? So, duplicates are allowed. So, as you can see, B is an object, it is an repeated object, duplicate object. Yes. So, duplicates are allowed in list. So, you should use list when you have duplicates, right. So, we should use list when we have ordered collection, when we are when we are concerned about this ordering, right. So, list is an ordered collection. Ordered means the way we have stored, the same way we are getting the output. So, if you have stored the data in this order A, B, C, B, you will always get, once you retrieve, you will always get A, B, C, B, right. There is a difference between ordered and sorted. It is not sorted, I am saying ordered, okay. So, rather than this, it is already sorted. So, let me make it in this way, C, B, A, say. So, I will always get C, B, A, ordered. This is not sorted, okay. The way I store, the same way I will get the output. So, list should be used to get the ordered and duplicates, right. Let us talk about set now. So, when should I go for set? Set is something which does not allow duplicates. So, if you see set is for intersection, set is intersection, right. So, if I am saying intersection, it is for common, right, it is not for duplicates. So, if I have C, input as C, B, a same input set A, B, what I am going to get here in case of set is a sorted and non-duplicates, okay. Set gives you sorted and non-duplicates, and that is in case of tree set actually. So, I will get A comma B comma C, yes, A comma B comma C. So, duplicates are not allowed and data is sorted. So, can you see that, right, data is sorted. So, I will get A, B, C and no repetitions, no duplicates, right, B is not repeated, okay. So, this is for no duplicates, and it is ordered, it is sorted, but for tree set we have one class called as a tree set, yeah, which implements this set interface. So, we should use tree set to get the sorted data, right. So, this is not for ordering, this is for a sorted and it is for an intersection, yes, unique data. So, we should go for a set in uniqueness. So, whenever we need a unique data, unique objects, go for a set, right. When I talk about queue, in case of queue, it is queue, we know the definition of queue, right. Queue is for FIFO, which works on FIFO, first in first out, right? So the way we enter the data, the same way we will get the output, right? So Q is for, it is FIFO type, first in first out, right? So from Q we again have a interface called as an DQ, which is an again the different part. So we can insertion and deletion becomes very easy in case of Q. So it can be inserted in front and can be inserted in back as well, into the tail as well, right? So insertion, deletion and searching of elements becomes very easier in case of Q. Okay, so we'll keep this Q aside for now, because most of the classes are added in JDK 1.6. so we'll not going in that detail. We'll be talking about set and list as of now, right? So the main difference between set and list is set doesn't allows duplicate, list allows duplicate. List is ordered collection, set is not an ordered collection. Okay, and the classes which are implementing these interfaces, these are interfaces, right? So we'll be using classes. So array list is the one class. I'll just make a note of those classes as well. So the one class what we have is an array list, and second class, important class what we have is an linked list. Okay, other than this we have a vector class as well, which is an deprecated class, which is no more in use. We don't use vector class nowadays. As an option for this we have an array list, right? Array list is a more better than it is better to use array list than this vector class. Okay, and in case of set we mainly have two classes which implement set interface. What are those? One is has set and the second one is a tree set. Okay, mainly we have two classes which implement set interface, that is an hash set and tree set, right? Both deals with the unique data, it doesn't allow the duplicates. Okay, and definitely tree set gives us the sorted data. Hash stands for random, hash doesn't gives you a sorted data. Okay, hash set is not for sorting, tree set is for sorting, right? In case of hash set, then what will be the order? That can be ABC. Yes, in case of hash set you will definitely get the duplicates, you will not get the duplicates, it is not for duplicate. Set is not for duplicate, no duplicates. When I say set, it is intersection. Yes, when I say set, no duplicates, right? That can be hash set and that can be tree set, right? So in case of hash set, no duplicates, but order can be anything, that can be ABC, BCA, CBA. We cannot predict the output, we cannot predict the order in case of hash set, but in case of tree set we can predict the order as well. It is always sorted. If I put BCA, I will get ABC and no duplicates. Remember this. Other than this, we have an interface called as a map. Let me talk about that as well. But it is not derived from collection interface. This is a completely a different interface. It's a completely different interface. Classes which implements map interface are same like set. Those are hash map and tree map. These are the classes which implements map interface. Okay, so now you may feel that when should I go for map type of classes and when should I go for map collection? So map is basically for key value pair. So whenever you have a data in key and value, right, so we should go for map. So this is for key value, right? So whenever, so if you have employee with, you have a data with called as an employee objects, right? So every employee comes with the ID. So you may want to store ID as an key and employee details as an value. So it becomes very easy to search, isn't it? Yeah, if I store anything or any data with some key, with some indexing, that becomes very easier for me to understand or very easier for me to retrieve or store a data, right? So if I store a data in key value pair, that becomes very easy for us or easy for or a client or for a user. It becomes very easy for user to retrieve a specific data directly. He can or we can search directly by the key, right? So whenever you need to store a data in key value format, go for map, right? How about sorting and how about sorting in this scenario? Yes, duplicates and sorting, if I talk about duplicates and sorting, yes, map, in case of map we have two objects now, key and value, right? We need to talk by considering both of these. Yeah. So duplicates, key are always unique, right? Even in case of hash map and tree map, key is unique, okay, values can be duplicate. Okay, keys are unique and values can be duplicate. And how about sorting? In case of sorting, we get a sorting only for keys, but that too only in case of tree map. Hash map is not for sorting. Tree map gives you a sorting, but sorted according to a keys. So, and this is not sorted by values, right? So, it gives you a unique and sorted by keys. Okay? You can have unique keys only, right? So, in case of tree map, you will get a sorting according to the keys, no duplicates. Remember this. That is what is the difference between list, set and map. So, now I can probably show you a complete framework. So, if you see a collection, from collection we have list, set and queue. So, from list we have array list and linked list. From set we have sorted, so from set actual classes we have as an this hash set and tree set. In case of map we have tree map and hash map, right? These are the internal interfaces again, right? So, sorted set and navigable set, yes. So, navigable set extends sorted set extends set interface. These are internal this is an internal structure, and tree set implements this navigable set. Similarly, tree map implements navigable map. Okay. This is an hierarchy in case of tree, right? Whenever we say tree, it is for sorting. So, tree set implements navigable set extends sorted set extends set extends collection. Same for map. Okay. So, once this framework or this hierarchy gets fitted in your brain, you will never forget collection. Collection is very simple. Yeah. Once you remember this, once you remember the difference between these collections, it becomes very easy to deal with the collections now. Okay. Now let us directly go for a demo, so that we already talked about the difference between list, set. Similarly, we talked the difference, we have seen the difference between a map, list and set, right. So, let us go for a demo and we will see the output as well, whether it is correct or no. Let me open Eclipse, let me go back to Eclipse. We will create a new demo for this. I will clear console as well. Let me create a new demo. I will say new Java project and I will say collection demo. Okay, I am creating a new project, collection demo. Inside source, I will create a new class and package. Inside package com.psl.set demo collections demo. Public static void main I have. Okay. So, we will see a demo for a list type first. We have list, set and map, main types. Okay? These are the core classes, core interfaces, list, set and map. Out of that, we will talk about list first. So, let me create a demo for list or array list. Okay. So, we have a class called as an array list which implements list interface, right. So, this is how we can create an object of list, a base type reference, this is an interface, list, object name is a list, new array list. Okay, and collections are of type generic type, that's why we get an open close angular bracket there. We are not talking about generics as of now. So if you observe a very important thing, I just forgot about I just forgot to tell you about the package, which package we are using. Let me note it down as well. So what package we are using is util package, right? So we need to import a package called as in java.util package. Okay, and star stands for everything, all the classes, all the interfaces what we are using are from util package. So whenever we deal with the collections, we need to import java.util. So I'll just remove this array list, I'll just put a star, so that we can use all the classes from collection interface from this util package, right? So this is how I can create an object of list, right? This is the one way, or you can simply say array list is equal to new array list. Okay, one and the same thing. Yes, and we just want to add the objects. So to add the objects, I'll put it something like this. We have a method called as an add to add the data, to add the objects. So assume we are adding some strings called as an a, b, c, the way we have added. Okay, so I'll say b, I'll add b first, just to check the ordering as well and duplicates as well. I am adding b, a and c, and again say a. Okay, so we have four data or four entries in array list, right? And as we are saying, it is ordered array list, right? Array list is ordered, it allows duplicate. So a is repeated, we have a duplicate data. Let me check this out. Let's print the data now. So if I say system.out.println, if I print this list directly, it can show what it contains. Okay, so if I print this list directly, it can show what your array list contains, what it has. So let me run. Can you see that? We have added the data the same way we are getting the output. We have added B, A, C, A, the same way we are getting B, A, C, A. It is not sorted, it is ordered, and duplicates are allowed. Simple. Okay. But actually, if you see, it is just displaying data, right? We are using in system.out.println, we are just printing a data. This is not an actual way to retrieve the data. So here is one more thing here, that you can remove or add a data, you can get the data by index as well. So you can use a method called as an list.getProbably, yeah, and as you can see index. So if I pass 1, so it will retrieve the value which is present at index 1. So I should get A here. Can you see? So index starts with 0, 0, and on first index I have A, and I am using list.get 1, get of 1. So as you can see, in collection classes we have many inbuilt methods which allows us to retrieve the data from any index, right, which can allow us to add data at any index. It becomes very easy to manipulate the data, okay, and that is why we are using collection. Similarly, we can remove data if we want. I can use a method called as an list.remove by the index or by the object directly. So if you want to remove it by index, so you can give index directly. I want to remove it by object now. So you can use an object name directly here. Let me print the object again, that is an list, array list again, right. So I should get A, B, so I should get B, A, C now. A is removed. Can you see that? Okay, but this is just displaying the values, as I said, as we discussed, this is just displaying the values, So what should I do to retrieve, to traverse through this collection? So we have two ways to traverse through the collection, either to use a for loop, yeah, and actually we should use a for each loop to traverse through the collection. So for loop, for each loop, or a iterator. Okay, we have something called as an iterator. So let's talk about for each loop now. So mainly we use a for each loop in case of collections to traverse through this. Okay, and we are using string type of data. Yeah, so I'll keep it object, no issues. As of now, I'll keep it as an object. So if you see, this is just a normal for loop. This is same like a normal for loop. A traditional for loop starts with the index starts with a 0, yeah, till the length of the collection and incrementing by 1. Okay, so after the colon we specify a collection or array through which we want to traverse, and before this colon we specify what type of data we want to catch. So for now this is an object type of data. Object is a base most class. This is a string type of data actually, but for now we have not specified the type here. To specify that, to simplify that, we should provide a generics here, something like this. I am not talking about the generics as of now, okay, but remember this, whenever you specify a data, you should always specify what type of data you gonna store in a collection. This is important, remember this. We are not talking about generics as of now, right, but remember this. So while defining generics, while defining any collection, just define it in this way. Okay, so this is something like a container. This is something like a container which has a label saying that you are storing string type of data. So whenever you store string, while retrieving you will always get a string. Okay, so that's why it is necessary to provide what type of, this is generic, so this is necessary to provide what type of data you are storing here. Okay, so in array list, after that open close angular bracket that defines it as generics, so you are storing string type of data, just define it. Okay, so now I can write it here directly, fine, and I don't need to worry about indexing here. I don't need to worry about the indexing. I don't need to worry about declaring an index, that is a variable I can directly print this object. This is how how I can traverse through the collection. Can you see BCA? We are actually traversing through the collection one by one. Okay, so this is called as an for each loop. It is starts with 0, index starts with a 0. This is internally an traditional for loop. The only thing is this is only incrementing loop and incrementing by 1. This cannot be used for decrementing loop, okay, or not even for escaping or for jumping from 1 to second level. This is directly to increment by 1 only, not to increment by 2. Okay, so this is incrementing by 1 till the length, whatever is the length. Okay, indexing starts with a 0. Yeah, this is the syntax. This is an syntax to use a simple for each loop. Similarly, we can use a iterator. Iterator is the one thing in which we use in case of collections, and this is again to traverse through the collection. So one thing is for each loop, second is iterator. So let's see how to use a iterator. Iterator is just a pointer. You can say that iterator is same like a pointer which points to the data. So we can use iterator something like this: collection name, that is list, object name, dot method called as an iterator, and it returns iterator object. Okay, and I am storing a string type of data. What type of data we have? We are retrieving string type of data ID. So this is how we create an object of iterator in case of collections. So iterator is to traverse through a object, to traverse through the collection, right? So iterator is just a pointer. It is same like a pointer to a data, yeah, by default, which points at the -1 location. It is not pointing to the actual data as of now. So, to traverse through this I need to use a loop. So, assume I can use a while loop for now with some condition, and we have a method called as an has next. Okay. So, as this iterator points to a data, but it is by default pointing to a -1 location before the actual data. So, if it is pointing to before data, it has to check whether the next data is available or no, right. So, what I am trying to say here, just pay attention, this is an data BACA. Whenever I create an iterator, or iterator is just a pointer which start pointing to this. Okay. But is it so? It is not actually pointing to the first data, it is pointing to the empty row before actual data. So, it has to check whether do we have a next data, that is why we have a method called as an has next here, right. It is just to check whether we have or no, do we have a next data, if we have then has next, then it will proceed. Yeah. So, has next returns boolean, if we have data then proceed ahead, then probably we can retrieve that object by saying it dot next. Next is because it points to the actual before actual data. Okay. Next is to retrieve that object, actual object. So, this is one way, and the second way is to use the iterator. Let me run. So, can you see that BCA is by for each loop, and the second BCA by the iterator. Okay. These are the two ways to iterate through the data. So, that is all, we are done with the list, and same thing we can do with the set as well. Let me show you by set as well. What I will do, I will just change the name of collection classes here. So, assume we use a tree set here. I will just replace this with a tree set. Okay. I do not want to use any of the methods as of now. I am just using simple, I am just printing it, and I am using for each loop and iterator. Okay. I will just remove for each loop as well. We will use a simple iterator. Let me see what output I will get. So, set is for sorting and to get the uniqueness, right. So, I will get what output I should get here, I should get A, B, C sorted, can you see, and duplicates are removed. There is no repetition, there is no repeated A, that is how simple it is. Let me talk about map. So, in case of map, let me create a tree map object. I will just replace this with a map, say tree map. In case of tree map, when I say map, so it is about key and value, right. So, you have to specify two type of data. So, assume first type is integer and second type is string. Okay. First type is integer and second type is string. So, here generic should be of two types now, and we do not have a add method as such. What we have here is a put method. So, I need to say tree map, I am modifying the same example. So, I will say map dot put, rather than add we have a method called as an put here, right. So, as you can see we have to specify key now. So, assume I am specifying key as in 102 and value as say A. Map dot put value as in 101 and value as say B. Map dot put say 105 comma C. Okay. We do not have list, we have a map now, object name is map. So, I will say map. Let me comment this iterator. iterator works in different way in case of map, so I'll show you that as well. So for now I'm just printing that map. Okay, so as we are using tree map, this means what? Sorted by keys, yeah, not by values. It will not sort by values, it will sort by keys and uniqueness for keys. So let me add a duplicate data, duplicate key. Okay, uniqueness and sorting is applicable for key, not for values. So it should get only it should retrieve only 101, 102 and 105. Can you see that we have only 101 sorted by keys, no duplicates. Okay. Values can be duplicate, even if I put a different value here, that's fine, but as the key is duplicate, so it will not add this, the previous one will be replaced. Can you see that B is replaced? This is added first, so it is replaced with this. So that is why I am getting 101D, 102A and 105C. Okay, so tree map is sorted by keys and the uniqueness is checked for keys, not for values. That's it. And in case of map, how I can use iterator is, only one thing I need to make a change here. I need to use a iterator probably on a key set, on an entry set. Yes, so I'll say map, as we have two data, right? I have key and value, so it will ask you whether you want to put a iterator, whether you want to traverse only the keys or whether you want to traverse through the complete entry set, right, or a complete data. Okay, so I can use it. I can say map dot entry set is to get everything, dot iterator. So map dot entry set dot iterator to get everything. So in that scenario, as I am getting both, and I should not specify this, generics will not be allowed because we have both integer and string, we are getting both, right. So let me print, let me run. Can you see? It is retrieving keys with the values 101D, 102A, 105C. If I say entry set dot iterator, similarly I can say key set. If I say key set, I will get only and only keys now. If I run, I will get only and only keys. This is how I can work with the iterator in case of map. That's all. So yes, and we are done with the demos of collections as well. So we have seen a demo for list, we have seen a demo for set, that is tree set, and we have seen a demo for map as well, that's a tree map. So, and yes, this comes to an end and we are done with the demos. So with this we have come to an end of our session. That's a very fantastic session we had. I hope you enjoyed this. I hope you have many queries related to these sessions or related to the topic which we have covered. And yes, definitely you can comment on that, definitely you can ask questions on that. So below video you have a comment section, you can ask your questions on that comment section. Thank you. Thanks a lot guys. Have a nice day. Bye bye.